guys, it's Micah with the Modern Einstein. Today I'm going to be doing another Science Talk segment, and I'm also going to be following up a unit conversion segment that I did. And today we're going to be doing some chemistry unit conversions, dealing with the mole. We're going to be able to take grams to moles, moles to atoms, and the other way around. So let's take a look at some things that we need to know. Starting off with some vocabulary that we need to know in order to be able to do this. So we can see over here, let's start out by defining what exactly a mole is. And I'm not talking about the furry animal that digs around in the ground. This is the unit mole, and that's all it is. It's exactly a unit. That's all. Just as we would refer to something as maybe a certain amount of meters or a certain amount of kilometers, well, this is what chemists use to refer to something as a unit in moles. And they just use moles because in this case what we're using it for, grams wouldn't be as accurate. So the word for word definition you can see right here. It's the amount of substance that contains as many particles as there are in exactly 12 grams of carbon-12. So what does this mean? It means if we had 12 grams of carbon-12, there would be X amount of particles in that 12 grams of carbon-12. So 1 mole is the amount of substance that it takes to fill that X amount of particles so that it's equal to the same particles as there are in 12 grams of carbon-12. So another thing that we would need to know, and we'll talk a little bit more about this when we convert to particles, is Avogadro's number, which is 6.022 times 10 to the 23rd. And this is the number of particles in exactly 1 mole of pure substance. And key right here, the number of particles, and this is why we use it to convert to particles, because if this is the number of particles in 1 mole of substance, then we can multiply our moles by this number to get how many atoms are in whatever we're dealing with. And when we do these unit conversions, another thing we need to know is the molar mass. And this is the mass in grams of 1 mole of pure substance. And another name for this would be the atomic mass. This is the little number under the element. And this is measured in grams per mole. And if you take a look at this periodic table up here, then the little numbers below the element are the molar mass. Can't really see it on this diagram, so I drew out the element that we're going to be dealing with. That's krypton, Kr, and the number below it is 83.80, and this is the atomic mass, or the molar mass, that we're going to use. One last diagram, and it plays a key role in converting. This allows us, I would write this down if you're taking notes, because this allows us to do what we're doing. If we forget how to do it, then we can use this diagram. If we have grams, and we can go to moles by dividing our grams by our molar mass, which is what we talked about in krypton. The molar mass is 83.80. And if we have a mole and we want to go to grams, we multiply by the molar mass. And if we have moles and we want to go to atoms, we multiply by this Avogadro's number, which is what we talked about down here. And this allows us to say, okay, remembering the definition of Avogadro's number, it's the number of particles in 1 mole of pure substance. So this allows us to multiply however many moles we have by Avogadro's number, giving us the number of atoms. And vice versa, if we have atoms and we want to go to moles, we divide by Avogadro's number. So let's get started here with the conversion. You can see right here I have 5 grams of krypton, and I want to see how many moles that is. So we can refer back up here to this diagram. I'm going to have to divide, you can see, by the molar mass, which is 83.80. So let's get started here. And we're following the same rules as the last video that I did on unit conversions. So we have 5 grams of krypton. I want to know how many moles are in 5 grams of krypton. So in 1 mole of krypton, there's this molar mass, which is 83.80 grams of krypton. And when we're just converting grams to moles, it's fairly simple because that's all we do. Because you can see we have here we have 5 grams of krypton. This is what we know, and we want to convert it to moles. And here's our conversion rate right here, and we're still following the rules of conversions. Grams of krypton right here, grams of krypton right here, they cancel out. So this is our conversion for moles, and all we would do is multiply straight across and divide, and we should get that in 5 grams of krypton there are 0.060 moles of krypton. So this gives us our conversion to moles, and we are following this diagram up here. So now I want to know how many atoms there are in 0.060 moles of krypton. So what this is allowing us to do is we have our grams, so let's just find out how many atoms are in 5 grams of krypton. We have to convert to moles first, and then we can use this. So you can see we have moles right here, this 0.060, and we want to convert to atoms. So what we're going to do is we're going to multiply by Avogadro's number. So let's do that. So we had 0.060 moles of krypton, we said. And we want to convert that to atoms. So what we're going to do is we're going to multiply. You can see we're going across, we're multiplying by Avogadro's number. So we can say in 1 mole of krypton, there are this Avogadro's number of particles, which is 6.022 times 10 to the 23rd atoms of krypton. So anytime we are going from moles to atoms, all we're doing is we're taking our mole and we're multiplying it by this Avogadro's number. And if you remember the definition of Avogadro's number, it is the number of particles in 1 mole of pure substance. So in this case, the pure substance is krypton, and we don't want to know we know that the number of particles in 1 mole of that is Avogadro's number, but we want to know how many is in 0.060 moles of krypton. So we're just going to multiply Avogadro's number by our number of particles. And if you do that, we can just enter that into our calculator. We can do 0.060 moles of krypton times Avogadro's number, which is 6.022 times 10 to the power 23. And that gives us 3.6 times 10 to the power of 22. And this is atoms of krypton. So now we found out that in 5 grams of krypton, this is how many atoms are in that 5 grams. And this is a big number, as you can see, because there's a lot of atoms that make up a molecule. So we can even work backwards and we can check this answer. So referring to this up here, say that we were given our atoms, which we just found out, and we wanted to get to moles. So this time we would divide by Avogadro's number. So let's do that so we can check ourselves. So say we were given this to start off with. We were given that we had 3.6 times 10 to the 22nd atoms of krypton. So we were given that. And we wanted to know how many moles there were. So we're going to divide by Avogadro's number. And the reason we can check this is because, remember in the definition of Avogadro's number, it's the number of particles in exactly 1 mole of pure substance. And what we did when we had our moles is we multiplied it by this to see how many atoms in total there would be. So if we have our atoms, and we want to get to moles, we're going to do just the opposite and divide so we can see how many moles are in atoms. So we're going to follow this same rules of conversion, and we're going to divide by Avogadro's number. So we can say we want to convert to moles, so we can say in 1 mole of krypton, their Avogadro's number of particles, which is 6.022 times 10 to the 23rd atoms of krypton. And this, you should get what we got before for moles, and it's 0.060 moles of krypton. Now, one thing I want to point out, I want to specify that if you plug this conversion straight into your calculator, you're not going to get this answer. What you need to do is you need to use parentheses or something like that. So how I would plug this into the calculator would be like this. We'd have our 3.6 parentheses times 10 to the 22nd, and we're dividing that by Avogadro's number, which is 6.022 times 10 to the 22nd. You can do it like this, or if you have the little E button on your calculator, you can do like 3.6 times E 10 to the 22nd. So you can either do it like this, using parentheses, or if you have an E button on your calculator, you can use the E to do that. So this covers our conversions with moles, grams, and atoms using this chart up here. This is key, and as you go along in this, you won't need to use this as much, but this will save you from messing up, because if you just follow this, if we have our grams, we can get moles with our molar mass. If we have moles, we can get atoms with our Avogadro's number. So that covers everything that we're going to talk about today. If you have any questions, please email us, and our email is on our YouTube page. Email us, and we would love to help you out so this will make sense. If something didn't make sense, just let us know what didn't make sense so we can help you. So this is mole conversions, and I remind you again that if you like the Modern Einstein, you can go on our website, and we have podcasts on our website that you can check out. So, like I said, email us if you have any questions, and we'll see you on other videos to come. Thanks, guys.